Okay, this is Newton's second law, which is F equals ma, but now you got a coefficient of friction. I'm not gonna lie to you, these are tough. We've got two situations here. We want to find the normal force and we want to find the acceleration of the system. And we have two different kinds of questions. One where the force is pulling up, essentially making this whole thing lighter, which you want to write that down. And this one, it's pushing down, which is essentially making this item heavier. Okay, and that'll you'll see what I'm talking about in a second here. So what we're trying to do is find the normal force. Well, in an object that's getting lighter, we've got to figure out how it's actually getting lighter. Well, it's getting lighter because of this y vector pulling it up. So your normal force then, if we were going to find it, where I'll do it over here. Your normal force for this one, since it's getting lighter, is going to be your force due to gravity pulling it downward, which is that way. So that's going to be Fg. And we're going to subtract off this. Well, what is that? That's Fy. So your normal force in this case is going to be Fg, which is 35 times 10, minus your Fy, which is what? Well, 55 sine of 35. And I'm running out of space, so I'll come over here. So my normal force then is going to be 350 minus 55 sine 35, which is 31.5. So there you go. Normal force is going to end up being 318 newtons. Some decimal, but we don't care. Just call it 318. Give us a number to work with now. Okay, so there's your normal force. We found that. For part B, it says find the acceleration. Well, before you find the acceleration, you need to know what's accelerating it. Well, that's accelerating it. What's that? That's Fx. But it's horizontal, which means that because of this coefficient of friction right here, we've got an opposing force of friction. So you remember how to do these? You go F equals ma. But F is actually Fx subtract Ff because it's net force. Mass is 35. Acceleration we're looking for here. Well, I'm going to go over here and I'm going to find my force of friction. Remember, your formula is mu Fn. So that means my force of friction is 0.05, that 318 that I found. So my force of friction is what? 16 newtons. So now I can go back over here. My Fx, I know is going to be 55 cosine of 35. Subtract the 16 that I found equals 35a. Solve that thing out for a. I'll just do it in one step. You should be able to do that by now. And you get 9.7 meters per second squared, positive. Because it's going to the right. So you can see, that's tough because first of all you have to identify it as lighter. Then you go over here and you find your normal force, and you find your normal force should be less than 350, which would be if there is no upward or downward. Then you have to go and find your friction, which is mu Fn. So that's that times that, which gives you 16. Then you got to take your Fx, recognize that and that, Fx and Ff are your net forces, subtract them, equals ma, solve for acceleration. So like I said, they're not easy, but there's a definite process to them. This next one, a little bit different because now it's heavier. So the very first thing we're going to do is we're going to find Fn. Well, it's going to be heavier than what? Well, it's going to be heavier than 50 times 10, which is 500. How so? Because I'm pushing her down with my Fy. So 50 times 10 plus Fy, which is going to be 200. Downward is, so it's going to be sine of 40. So my normal force then is going to be 500 plus the sine of 40, which if you do that is going to be 500 plus 128.5. And this time we'll keep the decimal just like last time we threw it away, just to make it slightly more complicated. 628.6 newtons. There's your normal force. Take that normal force, we'll go over here, we'll find our force of friction, mu Fn. That means 0.3 times 628.6. So my force of friction ends up being 188.6 newtons. There. Now I go to find my acceleration. I go F equals ma. Well, what's the accelerating force? It's this one. It's Fx. And my force of friction is opposing it, Ff. So that means I'm going to go Fx minus Ff equals ma. 50. Oops, and I don't know what that is, so I don't know why I opened a bracket. I'll close a bracket there. Solving for a. Fx is 200 cosine of 40. Ff is 188.6 equals 50a. And my spidey sense is going off here telling me that I don't know if this is bigger than 188.6. So plug it into your calculator and you'll find that it's actually 153. So if you go 153 minus 188.6, this is actually telling you that friction is bigger than your applied force. If this number is bigger than this number, it doesn't move. So does not move. And something that doesn't move has an acceleration equal to 0. So you don't even need to solve anything. So there you go. That's second law with coefficient of frictions at angles. It doesn't get much tougher than that.